Wordify is an essay expansion website or tool that allows the user to submit an essay for extension. It removes contractions and expands existing parts of speech using descriptive language. Our group consists of myself, so Serena, AK, and Raban. So once you open the app, you have the option to either log in or sign up, and we're going to start with signing up. If you were to sign up with an email or username that already exists in the database, then the website returns an error message that, in this case, the username already exists and tells you to choose a different one when signing up. And if you were to click sign up without filling out a field, it would give you an error message as well. So right now I'm testing up the sign up page and database by creating a new account, which is a test account, putting in a new email and a password, and then signing up for the account. As you can see, the website goes through. That means the process works, and this is what it looks like in the back end. These are the current accounts that have already signed up, and then as we refresh it, we can see the new test account that has successfully signed up as well. And this is what it looks like individually in each of the cells. As you can see, the password has been hashed out for security purposes.
In this application, we use a SQLite database to manage user accounts. The user table stores user details like username, email, and a hashed password. Flask SQL Alchemy handles the interaction between Python and the database. The database create all command creates the necessary database tables. When the app is first running, it creates a table called login with columns for username, email, and password, where username is the primary key, email, which is the unique identifier for each user, and password, it's stored in a hashed version for the user for security purposes. Once the user enters their username, email, and password, at the back end, the sign-up route receives the data. It checks if the username or email already exists in the database using user exists, and if it's valid, it hashes the password with generate password hash and creates a new user object and adds it into the database. And then in the front end, it redirects them to the main page. As for the login page, users provide their username and password in the login form, and then in the back end, the post login route fetches the username and it verifies the password with check password hash. If it's valid, it logs the user in and it redirects them to their account page or the main app page. If invalid, it's going to display an error message.
So this is what it looks like when I log in with my account on Wordify. It takes me to the main Wordify page, and this is where the main processing happens. We have a short description of what is Wordify and how to use it on the main page. Some other features we have is the navigator bar, which takes you to the account page, which has your username stored and shown, and you can edit your personal information. So as you can see, we have my username, my email, and we can change the password as well and update the information. And as well, we have the contact page, which is just our contacts.
On our main Wordify page, you can start by selecting a file, and as you can see, a file has been selected, test.txt, and the file extension is a .txt, which Ina will now explain.
So now for the backend process for file extensions, we have a function process file, which takes a file as input and processes it and finds the file extension. So it goes through this process by using OS path split text and names it with the variable file extension. So this is basically the file extension of the document that was uploaded. And if the file extension is a .txt file, then it just opens and reads the file for further processing. Otherwise, if a .docs file is uploaded, then it joins the paragraphs together and essentially turns them into a string. Otherwise, if any other file type is uploaded, then it returns an error message that it is an unsupported file type, because at the moment we only take text and doc files. After the upload button is pressed, once a user uploads a file, then the app saves the file in the designated upload folder section.
Once the user presses on the upload button, as you can see, it shows on the left column, which means it has been updated to our server.
So this is what happens when the upload button is pressed. This is in the upload route. So on the server side, this handles the incoming request. First, it checks if a file was uploaded and validates its type. And if not, then it returns either no file uploaded or no file selected. And then it goes through the process file function, which I previously explained, which essentially just breaks down the text or document into a string to be further processed. The current word count function is then called, which is essentially just a function that checks the length of the string. And finally, the sessions allow for live editing and basically store all of the extracted content into the sessions.
In the front end, as you can see, the name of the document the user uploaded is displayed, as well as the current word, and the text itself is shown in the left column. Now, as we press the extend button, this processes and extends the file and returns the extended version onto the website in the right column.
So looking at the main process text function, which does all of the extension, as you can see, we start off with two dictionaries called contractions with apostrophes and contractions without apostrophes. And these are essentially two dictionaries with contractions like we've, your, he's, she's. It then creates an empty list and it loops through each word in the text. And if the word is a contraction, then it essentially breaks it down like how it's shown on the screen right now and appends it to the empty list. Once the entire text has been looped through, it concatenates the list into a string using the .join string method. Once the entire text has been looped through and all of the contractions have been broken down, we have a special model that we're using from the Spacey library that was initialized earlier in the code. So the model is called token_model, as you can see here, and we have initialized it earlier at the beginning of our code, and we are using the Encore web model from Spacey. And you can see we also disabled some of the features so that our code would run quicker under the initialization. So we input the text without contractions into this model and initialize a new list called altered text. We then have a for loop that loops through the text that has been processed by the model, and we have a variable word, which is essentially each word in the text, in the process text, and then pause, which stands for part of speech, which is each part of speech of each word, and then also dependency, which is the dependency of each part of speech. So for example, for a verb, the part of speech would be labeled as verb and the dependency would be labeled as root in case if it's a root verb. Now the dependency part is important because we're not processing every single verb, adjective, and noun. We are only processing specific types like verbs. We are only processing root verbs to help avoid grammar mistakes. Now as the function loops through each word in the text, it checks if it's an adjective, verb, or noun. And for example, if it were to be a verb, then it creates a new object of the verb class and inputs the word inside the object. So this is an example of how the verb, noun, and adjective classes look like. It starts off with a list of descriptors, which are lists of positive, negative, and neutral descriptors to precede the word with. And then we have the analyze sentiment method, which puts the word through a sentiment analyzer model that we used from Hugging Face and also initialized previously at the beginning of the code. This allows us to determine if a word is positive, negative, or neutral, and then choose a descriptor based on that context. Then the class returns the descriptor along with the original word. It does this for each word in the text, and if it is not a part of speech, then it just appends it to a list. It removes all the punctuation and then returns the final string.
The difference in the word count is displayed, and our program has added 77 words to the text. All parts of speech that had descriptors added before them are also highlighted. The user can then download the updated file. Here is another example of just contractions and how it looks like when they're expanded.
We also have a live editing feature on our code. The text area element in our JavaScript code listens for an input event. Every time the user types something, the input event is triggered. Once the user has made changes to the text, they can click on the Save and Extend the Edited Text button. This triggers the Save Updated Text function, which sends the updated text to the server using a POST request. Then the user can download the updated text.
So as you can see here, we edited the left column a little bit and added our own text, and we can go ahead and click the save and extend the edited text to extend the edited text, not the original file, and it gives us a confirmation message and gives us the extended words.